The last conic shape is parabola. So let's start off with a definition like we always do. A parabola is the set of all points in a plane. The set of all points in a plane, comma, equidistant from a given point, that given point is going to be called a focus, okay, and a given line. What? Given line? Okay, the given line is going to be called a directrix. Okay, and that's the dead giveaway when you're looking at these definitions that you are dealing with a parabola. He's the only shape that has a line. Okay, so you're going to be equidistant, the same distance away from a point as you are a line. Let's just do some basic review. I know that we've studied parabolas before. So when you have y equals x squared, the parabola is opening up, but a negative x squared, the parabola is opening down. Okay, we are also going to be studying the horizontal parabolas in this chapter. So if you have x equals y squared, you are passing through the origin opening to the right. And in negative y squared, you are going to be opening to the left. Okay, let's just practice a couple of graphs here. Refresh our memory on parabolas and how they grow. So you can keep the parabola in this form, but the standard form in this chapter would be to get the number by the y minus 2. Okay, and I think I am going to do that because for this entire chapter, we have the number for x by x, the number for y by y, and then it's change. So I think we're going to do that just so all the shapes are consistent. So the vertex would be 3, positive 3, comma, positive 2. The old way is we changed this one and didn't change this one, and this meant go to the right and go up. So I think we're going to start doing it that way. If you do it the other way, that's fine. What does this 1/2 number mean? A 1/2 out in front. That means vertical shrink. Vertical shrink in half. So let's refresh the growth pattern of a parabola. He goes over 1, up 1, over 1, up 3, over 1, up 5, over 1, up 7. But this one is going to have some vertical shrink to it. So instead of going up 1, 3, 5, 7, we're going to go up 1/2, 3/2, 5/2, and 7/2. Okay, this graph, x squared being positive, opens up. So let's go to 3, 2, get our vertex on the graph paper there. 2, 3, 2, we're opening up, and now we're just going to use our growth chart. Over 1, up 1/2, over 1, up 1.5, takes me to the corner of a box. Over 1, up 5/2, that's 2.5. Over 1, up 3.5, half plus 1, 2, 3. Oh, I'm right at the top of the graph paper, right at 10. Same thing on this side. Okay, so here is the parabola that is opening up. So everything I'm doing right now is review. We've studied all this stuff. We are going to now apply it to a parabola like this. Okay, so the parabola has a different opening. When it is y squared, it's either left or right. Since it's a negative, this graph opens to the left. The vertex is change. So tell me the x number first. Positive 2, and the y number is positive 3. Okay, so the vertex is at 2, 3. 2, 1, 2, 3. It opens to the left. There's no stretch or shrink. So really what people tell me works out best for them is they just turn their graph paper, they do the regular growth chart, and then they'll turn their paper back, but they make sure that it's growing to the left. Over 1, up 1, over 1, up 3, over 1, up 5, I don't think we can fit 7 on the graph paper. So here's the parabola. It's growing to the left, just like it said it was, once I turn my paper and face it back up. Okay, so that's the basic growth pattern. Those are the 4 types. So let's show you the official standard form of a parabola for both the up, down, and the left, right. Okay, so standard form. If they open up or down, we're going to do it this way. Y minus k equals a times x minus h squared. Remember, when you're dealing with a parabola, only one variable gets squared. Okay, if they open left, right, then you start with x minus, the letter that goes with x is always going to be h, equals a y minus k quantity squared. Okay, so the parabola, that would be opening up or down. I'm just going to put the vertex right here in quadrant 1. The parabola is going to be opening up or down, depends. Okay, so the vertex is right there. There's the vertex. Now I need to get a focus. Okay, so what I'm going to do is I'm going to put the focus, of course, inside of the parabola, just like they were inside of the ellipse and inside of the hyperbolas. So that's the focus point. Okay, now how do you do this? If you go so far up and get to the focus, that's a distance of p. If you go p units up and find yourself at the focus, then go back to the vertex, go p units down, and that is where you will find the line. The line that's called what? The directrix. Directrix. This line happens to be a horizontal line, so don't forget about your Vux-Hoy knowledge. And so this would be a y equals equation. Y equals is a horizontal line. Okay. There's also something going like this, going straight down the middle, okay, cutting a parabola in half, of course, and that is a vertical line, so that would be an x equals. And do you know what the x is going to always equal? It's always going to equal that vertex x value, x equals h. X equals h is the line of symmetry. The line of symmetry cutting the parabola right in half, or LOS, as it's sometimes abbreviated. I will do the same thing over here. Let's draw a parabola that's opening left or right. Maybe I'll just draw one opening to the right. So here's a parabola, and there's the vertex. If you go p units to the right, what point is that? That's the focus. If you go p units to the left, then you find yourself at the directrix. And in this case, the directrix is going to be a vertical line. Okay, so here's the directrix. And in this case, it would be x equals because it's a Vux. Okay, now this P is the distance from focus to vertex and then vertex to directrix. So the formula, how do you calculate P? It's 1 over 4a. And that a value is the vertical stretch shrink, or the shrink number that you find out in front of the parentheses. So that's how you calculate the p value. Then you'll know how far to go up or down, left, right, to find the focus and directrix. If you have a positive p value, then the parabola is going to open up or right. Up or right. If you calculate and you end up with a negative p-value, that means your parabola is opening either down or left. Okay, so you could tell if you got the right answer based on your picture and stuff. So let's do another graph this time. We're going to get a little fancier with our new information. Okay, so we're ready in standard form. So when you look at this, this is an x equals y squared. So this graph is opening left and right, but there's a negative. So this graph is going to be opening left. The vertex, the x number, change, is 2, the y number, -1. p-value is 1 over 4a. 1 over 4a. And the a value here is negative 1/2. So let's do some calculations. Half of 4 is 2. That's a negative 2. So I think I'm going to write negative 1/2. Okay, I'm going to go graph it, and then I'll answer some of these other questions once I actually see it. Okay, so how do parabolas usually grow? 1, 1, 1, 3, 1, 5, 1, 7, except this growth right here, it's not over and up because this parabola is opening to the left. So this is going to be growing left. Unless we just turn our paper and do it the usual way. There is some shrink. So what we need to do is chop all these in half. 1/2, 3/2, 5/2, 7/2. Okay. So let's get the vertex on there. 2 to the right, 1 down. Here's the vertex. And the parabola is going to be growing to the left. Do you guys like to grow left, or do you like to turn the paper and do it the regular way? Most people like to turn the paper, so I'll do that. So, over 1 up 1/2. Oh, I'm so glad these boxes are big. Oh, you're welcome. Over 1 up 3/2, 1/2 and 1. I'm on the y-axis, are you? Y-axis. Okay, over 1 up 5/2. That's 2 1/2. 1, 2 1/2. Okay, I don't think we can fit 3 1/2. So here's the parabola. The parabola is growing to the left. You're going to see it as soon as I turn the paper back. Oh, nice parabola. Well done. Okay, so it's growing to the left. I have the vertex. Let's see, what else do we have to plot on our parabola now? Graph the parabola, graph the focus. Okay, and to do that, you're going to use the p-value, which we calculated to be negative 1/2. Now, why is the p negative? Because the parabola is opening left. So, of course, it's negative. So, from vertex here, go 1/2, and that is the focus. And if I go 1/2 this way, you're going to get a line. In this case, it's going to be a nice vertical line. Okay, and that is the Directrix. Now that I see this vertical line, this is definitely a flux. So the Directrix is x equals, let's see, 1, 2 1/2, 5/2. Or you could say 2 1/2. Or I guess in this case you could say 2.5. You don't have to say 3 answers. Okay, how about the focus? I see it right there. It's 1 1/2. So I'm going to say 3/2 for the x, and the y value is negative 1. And LOS, that's a line of symmetry. LOS, all parabolas can be chopped right in half, line of symmetry. This is a horizontal line, so make sure you say y equals, and it's right at negative 1. Let me just say again the definition of parabola. The set of all points in a plane equidistant. Okay, so let's take a look at this point right here. Equidistant to the focus as it is the directrix. So if I draw a distance here from this point to focus, let's go straight there. That distance, tick mark, should be the same distance as it is to the line, to that directrix, tick mark. These two distances, to focus and directrix. The set of all points in a plane, equidistant to focus and directrix. The set of all points in a plane, this distance here should equal this distance here. That's how they form a parabola. This distance here, tick, tick, equals this distance here, tick, tick. Okay. All right, let's do a couple of more. When you are completing the square on a parabola, the good news is there's only one letter that has the square, so you only have to complete the square on one of the letters. Okay, so let's take a look at x squared here. I am going to keep x squared and 8x on the left. And then everybody else has to go to the right. So negative 12y will go to the right as well as plus 8. You only complete the square for one variable. All right, half of 8 squared is plus 16. Add 16 to the left, so I have to add 16 to the right. So now we have the quantity x plus 4 squared equals negative 12y plus 24. And now we have to get y equals. So what I'm going to do is divide all three of them by negative 12. Okay, so now we have, maybe I'll write this stuff as the left-hand side. Y minus 2 equals negative 1/12 x plus 4 quantity squared. Okay, so this is standard form. Okay, how about the vertex? The vertex would be negative 4 positive 2. It's x squared. I always think back to Algebra 1. It opens up and down, but this one's going to open down. Let's calculate a p-value. The formula for p is 1 over 4a, and the a value is negative 1/12. So we've got 1 over negative 1/3. So the p-value is negative 3. Okay, let's figure out how this one's going to grow. The parabola is usually 1, 1, 1, 3, 1, 5, 1, 7. But since I see a 1/12, that means that all these numbers have to get divided by 12. 1/4 divided by 12 is 5/12. 7/12. Oh, yuck. Let's see, maybe I'll write this as 3/12 just so I can see the 12s. If we add 1 plus 3 plus 5 plus 7, is that even going to be a full box? Yeah. 1 plus 3 plus 5 is 9/12. So this is not a complete box, but then once you add the 7, you go past it. Okay, that's good to know. So let's maybe zoom in here so we can graph our parabola. We said it's opening down. First, we got to go negative 4, positive 2, plot our vertex. Okay. Over 1 down a 12th. Yuck. Over 1 down 3/12. 3/12. 1/12 plus 3/12 is 4/12. So that's not a full box. Over 1 down 5/12, that's still not a full box. But when I add 7/12, I'm finally past it. Okay, so the moral of the story is this parabola is pretty wide. Okay, a couple things are going to happen. If you have a really nice p-value, then these numbers are really ugly. If I give you really nice numbers to graph, then the p-value is going to be a fraction. Okay, so that p-value actually forms the shape of the parabola. Let me show you how that works here. So let's do our focus point by going negative 3 units down. 1, 2, 3. So as you pull this focus point down, get it farther down, a nice big fat number, the parabola opens up wider and wider. And then as you put that p-value really small, like a fraction close, then the parabola gets skinny. Okay, so here's the p-value going down to the focus. Let's go 1, 2, 3 units up. This is going to be the horizontal line. What's that called? That's called the directrix. The directrix is a horizontal line, so that's going to be a hoi. That's going to be y equals, count the boxes, 5. Focus points ended up being where? Negative 4, comma, negative 1. And is there a line of symmetry? Well, of course. The line of symmetry right here is going straight down the middle. That's a vux. That's x equals. I don't even have to look at the boxes because I know it's going to go through that vertex point at negative 4. All right, let's complete the square one more time for parabola. So I'm going to complete the square for the y's. y squared plus 6y. And then 8x minus 25, push those guys to either side. Half of 6 squared. That's going to be plus 9 and plus 9. So now we have y plus 3 quantity squared equals 8x minus 16. But remember, you have to get x alone. We can't have a number there. The number's supposed to be out in front of the quantity squared. So let's divide each and every one of them by 8. So that cancels and makes x minus 2. X minus 2 equals 1/8 times y plus 3 quantity squared. Okay, standard form for the parabola. Nice. Vertex, change, is going to be x number 2, y is negative 3. This graph is going to open, let's see, with the y being squared, either left or right. It's going to open to the right because it's a positive 1/8. The p-value is 1 over 4a, and the a is 1/8. So that's going to be 1/2. So the p-value is 2. Ah, it's one of those. Nice, easy p-value. Hard chart with icky graphs. Great. Okay, so let's see. The regular parabola is 1, 1, 1, 3, 1, 5, 1, 7. But the 1, 3, 5, 7 numbers need to get divided by 8. So we've got 1/8, 3/8, 5/8, 7/8. 1/8 plus 3/8. That's half a box. Plus 5/8. Okay, so here we're going to be past the full box. And 9/8 plus 7 more. 9 plus 7 is 16 divided by 8. So right here, that's going to equal 2. 2 full boxes. Okay, so the vertex is at 2, negative 3. The parabola is going to open to the right. So I think I'm going to turn my paper one more time because I'm better doing it the way I learned the first time around. We're going to go over 1 up 1/8 of a box. Over 1 up 3/8 of a box. So that's exactly half. Over 1 up 5/8. Okay, so we're past the full box. And then over 1 up 7/8 takes us to 2 boxes up. 1, 2 boxes up. Right there. If you're not sure, you could always take a point and plug it into the equation. Okay, let's go ahead and put this back. But like I said before, when you have a larger p-value, like 2, the p-value is really nice. As you pull it, the parabola gets wider, wider, wider. Big fat parabola. So the p-value is 2, positive 2. That makes sense because it's going to the right. There's the focus. The focus is at 1, 2, 3, 4, negative 3. The directrix, this time, let's see, we're going to go 2 units to the left. Here's the directrix right there on the y-axis. That is a vertical, so that's going to be a vux. The directrix is x equals 0. And is there a line of symmetry? Of course. Slicing this parabola right in half. That's the horizontal. That's y equals 1, 2, 3. Oh, the y number, of course, negative 3. A little introduction to completing the square and doing some fancier work with parabolas. We're getting close.